All right, so I think this is recording. Let's take a look here at number 2. We have a polynomial function. We want to factor it. We do not have, however, the tools to do that. We have this 2x to the fourth minus 7x cubed plus 6x squared plus x minus 2. Well, I do have this table down here. If x equals 1 is a 0, then in factored form, x minus 1 is going to be a factor. And so I need to figure out how to write the other factor. Well, synthetic division can help me do that. So if we take this and divide, now let's make sure when we do our synthetic division that we don't have any missing terms. So we've got 4, 3, 2, 1, and a constant. So that looks good. So 2, negative 7, 6, 1, negative 2. If this really is a 0 of this polynomial function, well, I'll get a 0 remainder. So let's see what I get here. The 2 comes straight down. Then I multiply and add, multiply and add, multiply and add. All right, so I do get a 0. So that this x minus 1 is a factor. And now this 2, negative 5, 1, and 2, I look over here and I see that this is to the 4th degree. So I know this 2 starts out 2x cubed. All right. But now I notice that x minus 1 right now is being raised to the first power. In my table over here, it said it had a multiplicity of 2. So what that tells me is that this 2x cubed minus 5x squared plus x plus 2, this guy is also divisible by x minus 1. So I want to do synthetic division again, only this time I'm doing it on this polynomial. So let's write down our coefficients: 2, negative 5, 1, and 2. All right, so if this really is a factor of this, I should get a 0 remainder. Bring down the 2, multiply by 1. Bring down negative 3, multiply by 1. Bring down and multiply by 1. So what do you know? I get a 0 there. So that's going to help me a lot, because now I can factor what I've highlighted over here in gold. So I can write my function p of x is equal to, well, I've got x minus 1. And because of this 0, we've just shown that I have another x minus 1. I'm just going to write it as x minus 1 squared. And this 2, negative 3, 2 is 2x squared minus 3x minus 2. All right, now that leading coefficient there is not equal to 1, so it makes these a little bit more challenging. Let's do our x method. The first term times the last term, and the middle term. And let's try to find two numbers that when multiplied together give us the top value, but when added give us this bottom. And there we have it. All right. So since the leading coefficient is not equal to 1, we can't use our shortcut. So we're going to have to chart this. Along one diagonal, we put the first term and the last term. So we've got 2x squared minus 2. Along the other diagonal, the two values we found from our x. So we factor now both horizontally and vertically. So I don't know why that's erasing. Here, both of these are divisible by -2. These are relatively prime, so we've got a 1. These are both divisible by x. These are both even numbers and divisible by x. So let's check. 1x times 2x, 2x squared. 1x times 1, 1x, -2. And -2 times 1, right there, -2. So -2 times 2 at -4. Yeah, everything checks. Everything's really good. So let's rewrite this in factored form. We've got x minus 2 and 2x plus 1. So I really can't factor this any further, so I'm ready to complete the rest of my table up here. They've already put in the 1 for me from this factor, and I already said the multiplicity was 2, and if that's a touch, in this next one here, we have a first degree, x equals 2, multiplicity of 1, and it crosses through the x-axis. Now, over here, if we solve for x, subtract 1 and divide by 2. So x is -1/2. The multiplicity is 1 because you have an exponent of 1 right there. And how will it intersect the x-axis? It will cross over it. All right, so there's our answer for number 2. No, wait, let's box in our factored form. They wanted us to factor this polynomial, but also indicate the zeros, the multiplicity of the zeros, and how it intersects the x-axis. So I hope that helps, and I will talk to you later. Bye.